Before we talk about the course itself, I want to begin with what makes physics really exciting. At A level, students dive into some of the most fascinating ideas humans have ever discovered. How tiny particles like quarks and leptons build the universe, how electricity and magnetism power the technology that we use every single day, how waves and quantum behavior influence the smallest scales of nature, and how forces and energy explain everything from roller coasters to rockets. Physics blends our natural curiosity, creativity, and real-world problem solving in a way that not many other subjects do. On the screen, I've picked just a few modern-day examples of how physics shapes the world around us, and these really do truly only represent a snapshot of its impact today, and this might be an idea of some of the careers and future fields that our students might choose to go into beyond A level. The course is taught over 2 years and is carefully structured to build confidence and understanding. In Year 12, the focus is on establishing a strong foundation through the core topics of physics. Many of these ideas will be familiar from GCSE, particularly for students who studied separate science, including mechanics, materials, electricity, and waves. This year gives students the time and the space to secure these essential concepts, ensuring they're fully confident before going into Year 13. There is no disadvantage for students coming from combined science. Any gaps are deliberately addressed and supported, so all students can progress together. Alongside this consolidation, students are also introduced to completely new areas of physics, which is exciting. These ideas include particle physics, exploring the fundamental building blocks of our universe and how it began, as well as deeper and more sophisticated treatment of waves, including their behavior and real-world applications like medical imaging. Once Year 12 content is secure, the students then move into Year 13, where physics becomes a bit broader and a bit more challenging. Topics include further mechanics, thermal physics, fields and their consequences, and nuclear physics. The course then finishes with an optional topic, which will be chosen by us in the department based on strengths and interests of the cohort. Options could include astrophysics, medical physics, engineering physics, turning points in physics, or electronics. But overall, this course is designed to build confidence early, deepen understanding over time, and give students both the knowledge and the skills needed for further study or careers in science and engineering. This course also includes 12 required practicals across the 2 years, building confidence in experimental technique and scientific thinking, crucial for those going on to kind of have careers in kind of real world science. So upon successful completion of the required practical skills, students will be awarded a practical endorsement certificate for A-level physics. Now, although this does not contribute to the overall grade, it is a highly desirable qualification that many universities now look for as part of their entry requirements. To study A-level physics, students will need at least a grade 6 in GCSE physics or a 6.6 in combined science. Because physics is built heavily on mathematical reasoning, we also require at least a grade 6 in GCSE mathematics. These requirements ensure that students have the foundations they need in order to cope with the challenge and the pace of the course. And it is a demanding course. A-level physics asks students to think deeply, to apply concepts in unfamiliar contexts, and to engage in analytical, multi-step problem solving. It builds on everything they've learnt at GCSE, but it does move far beyond it, linking ideas, exploring real-world applications, and developing practical skills through hands-on experiments. Because of this, the most successful physics students share some key attributes. A strong work ethic, with willingness to revise regularly and consolidate learning in their own time. Resilience, a bit of grit, as it's normal to struggle with these new concepts before they click. And struggling is great. Struggling is how we learn. Independence, so the ability to manage their own time, to use resources effectively. We will do everything we can to provide students with all of the resources on multiple different platforms, whether it's textbooks, videos, past paper questions, news articles. etc., etc. But it really does come down to the students' independence and what they want to take away from it. And then lastly, curiosity, the desire to ask why and how rather than simply memorizing facts. That satisfaction of being able to solve a problem that we give you from the skills that we've taught you. And we tend to call that a physics itch. Now, we do recognise, of course, that independence doesn't necessarily mean working alone. So this phase of post-16 education requires a strong partnership between us and students. And it also requires a significant commitment to independent learning. So we structure this by expecting a minimum of an hour for an hour of self-study, which we can support with online platforms, textbooks, specialised exam question booklets, all helped and designed to develop crucial academic discipline. We try to ensure transparency with regular reports so students and parents know their current working grades with no hidden surprises. And we also maintain open communications home while providing a strong safety net of teacher support in school. That could be extra explanations, practice questions, and guidance on exam technique both during, after school, break, lunch, whenever the students need it. All starting with an early check-in to confirm the suitability of their course and set them up for success later on. So aside from being a really fascinating subject, it is one of the most respected A-levels you can take. Universities value physics because it demonstrates logical thinking, quantitative skills, and the ability to tackle complex problems, all qualities that are high in demand. An A-level in physics can lead to a wide range of careers, including engineering of all varieties, so mechanical, civil, electrical, aerospace, chemical, medicine and healthcare technologies as they're ever changing and ever developing, architecture, computer science, data science, AI, that's very rapidly increasing at the moment, finance, economics, analytical roles, renewable energies, climate science, environmental research, robotics, electronics, telecommunications, physics, astronomy, and scientific research. The list goes on and on. Even degrees that don't directly involve physics, things like law or business or humanities, view physics favourably because of the rigorous problem-solving skills you've developed by doing the course. And employers consistently rank physics students as strong critical thinkers who can approach challenges logically and creatively. In short, physics opens doors. It prepares students not only for higher education, but for a world that increasingly relies on scientific understanding and analytical thinking. All A levels are not equal. When you choose your subjects, you're not just picking what sounds interesting, you're choosing the doors that you want to open for your future. Ask yourself this: which A levels does no degree actually require? Students often say things like media studies or even psychology, and that's the point. Some subjects simply don't give you additional options. But physics is different. Physics is one of the most respected and versatile A levels you can take. It doesn't just support careers in science and engineering, it strengthens applications for economics, architecture, computer science, biomedical fields, and even competitive apprenticeships should you choose not to go to university beyond A levels. It shows universities and employers that you can think logically, solve complex problems, and handle challenging ideas. And unlike subjects that sound right for certain degrees, like law for a law degree, which you don't actually need, physics is a subject that genuinely expands your choices. It keeps pathways open, it tells people you're capable, resilient, and ready for demanding work. So again, this slide is much the same. This is the link between earning, so how physics compares to other degrees. So because physics teaches problem solving, maths confidence, analytical thinking, these are the skills employers pay a premium for. Fields that welcome physics students include engineering, finance, tech, data, AI, and they consistently rank among the highest paid careers. So even if you don't become a physicist, Physics signals that you can handle difficult, high-level work, and that opens doors to the well-paid opportunities that are out there. So I think I've mentioned most of these skills at some point somewhere during this presentation already. And the key takeaway here is that even if you don't go down a physics pathway beyond A level, there are so many transferable skills you will gain from taking this course. And these are the skills that every employer wants, no matter what industry you move into. So in summary, physics gives an insight into the fundamental way the world works. Studying physics develops your critical thinking and your problem-solving skills, whilst being a really versatile subject, opening a huge range of doors for potential future careers. It's a global enterprise and it will offer you the opportunity to work abroad or international research collaborations, should you choose to. And it's what drives our technology advancements, which impacts our society, the environment, and our economy. So the main takeaway is if a student wishes to take A-level physics next year, that the course requirements are a grade 6 in science and in maths. Should you wish to find out some more information, feel free to log on to the school website into the sixth form area where you'll find extra information. Equally, you can come and talk to either myself or Mr. McDermott about the course itself. Talk to some existing sixth form students because they'd be some of the best insights into the course. And alternatively, if you want to know a bit more about the course structure, log on to the AQA website and you can look at the physics exam specification for the A-level course. Thank you for your time this evening, and if you have any further questions or queries, please do not hesitate to contact me. Thank you.